Okay, so a transformation, what is it, or what makes a transformation a transformation? A transformation, I'll define it here for us. Okay, my pen's dying here. Can you guys read that okay? Can we read that okay? Transformation. Y'all can read that okay? All right. Transformation is a function, okay, that changes the position, okay, shape, and or the size of a figure. Okay, a function that changes the position, shape, and or size of a figure. So that means, right, that it could just change the position. Okay, a transformation could just change the position, like where it's located, where the shape is located. It could alter the shape of the shape. So you could potentially, have one kind of triangle, and then under the transformation change it to a different kind of triangle, something like that. Okay, and or it changes the size of the figure. So it could combine all those things together too. Okay, to change things around. All right. Like I said, we're going to start real basic here. So the idea is that we take now, and I don't like the way that this is worded, but for whatever reason, this is what we call it. Okay, we take something called the pre-image. That's also known as the original. Okay, so I'll put in parentheses beneath that the original. Okay, and I really don't like that word pre-image, but that's the way it's described. Okay, so we take the pre-image, and then that pre-image or the original undergoes a transformation to become, and what do we call it? Once the original undergoes a transformation, or once the pre-image undergoes a transformation, we call it the, what do you think? If it's the pre-image and we transform it, it now becomes the, well, it becomes the image. It becomes the image. Okay? The image is like the transformed figure. Okay? And there's no other name for it. So the pre-image becomes the image, or in other words, the original becomes the image under transformation. All right? That means, so for example, if I take a point P, for example, okay, that's like the original or pre-image, point P. Under the transformation, we label that no longer as P, because that could get confusing, right? If you have two P's up on the graph, or the picture, so we take point P and we transform it to P prime. Okay, we put a P and a little apostrophe and that means P prime. It's like, yes, I think that's where like Optimus Prime gets his name. He's a transformer, and he's got a prime there. Serious, right? And not only that, but what is the word Optimus? Optimus means best. So best transformer. I mean, I don't know, guys. Optimus Prime. It's in his name. So there you go. Things are named that way for a reason. You guys know, like, for example, Darth Vader in Star Wars, right? Vader literally means father in German. So it's like, no one should have really been surprised that, like, he was Luke's dad, because it's like, well, his name's Darth Father. So, but anyway. Characters are sometimes named for a very important reason. So whenever you're watching a movie or something like that, pay attention to, like, the names and stuff. It can be important. If you read the Harry Potter books, there's a lot of, like, meaning in their names, too. So anyway. Okay? So, the kinds of transformations we're going to concern ourselves with today, there's four major ones we're going to look at. Okay, we're going to look at the slide, right, the flip, and the turn. Okay, but we're not going to call those slide, flip, or turn. Okay, we're going to call the slide is, like Antoinette said earlier, a translation. Okay, translation. Flip means reflection, and turn really is a rotation. Okay, and we need to be comfortable with using those terms, okay? Because I'm not going to be using the words slide, flip, and rotate. Okay, if you use them, I'll listen to you. We want to mature our vocabulary. Okay. There's one other kind of named transformation. There's like a billion transformations that don't have names, but these are named transformations because they happen so often. And there's one other transformation that we're going to talk about more in depth at another time, and that's called a dilation. Okay? Anyone have any idea what a dilation does? What does a dilation do? Yeah, Eric? Changes the size of the shape. Exactly right. Now, Eric, have you done dilation before? How did you know that?
Dilate usually means like make it bigger or smaller.
Ah, very good. Yes, dilation does not necessarily mean it has to get bigger. It could get smaller, right? So you have to keep that in mind, right? I'm trying to think here, like your pupils, right? You can describe your pupils as dilating, right? And that means they're either get bigger or smaller. It doesn't have to be, one certain direction. But yeah, it has to do with a change in size. Okay. So yeah, dilation. All right, so let's actually do some transformations here. So let's graph here, and we're going to graph. Let's see. So we're going to need to draw some grid in here. So let's draw our axes. So our y-axis to go from 5 down to -5. Okay, and then also make your x-axis go from -5 to 5 as well. And that should fit everything we need. If you want to number your axes, you can. You don't have to number it like I did. I did it just for you guys to be able to see. But you don't need to number it, okay? If you're doing a test or a quiz or your homework or whatever, if you don't number the axis, I'm going to assume you're counting by ones, okay? You don't have to number it. I'm going to number it here just because, but you don't have to number it. If you don't label it, I'm going to assume you're counting by ones. If you want to count by a different number, then you need to indicate that to me, like 2s or 3s or 4s or whatever. You have to indicate that, but otherwise, we'll count by 1 there. Okay, so there's our axes. I'm going to put down these points too. So while you're drawing that, here, let me get these points. So we'll put point C right there at the origin, point B right there, and then point A up here on the y-axis. And that creates a triangle. Okay, so there's our original shape right there. All right, and so we're going to perform a transformation on this shape. We're going to perform a transformation, and we'll have you guys identify what it is here. Okay, so let's see. So we're going to take our original coordinates x, y, right? And the transformation we're going to do here is going to take those coordinates x, y, and have us do x minus 4 and y minus 3 to those coordinates. Okay, so x minus 4, y minus 3. So these are like our pre-image coordinates, and then these will end up being our image. Okay. This type of transformation notation is called coordinate notation. This is one way to kind of tell you what to do for a transformation, right? This tells us exactly what to do for our transformation. So we need to transform all of our points here, right? Am I going too fast for anyone, by the way? Do I need to slow down? We're all good? Okay. So A's coordinates are 0, 4. B has coordinates 3, 0. And C has coordinates 0, 0. Okay, so those are the coordinates. And then we're going to transform those By the way, does anyone want to predict what kind of transformation this is going to be? Yeah, Robbie, what do you say? Say it's a translation. Okay, can you give me more specifics about the translation? Like, okay, which direction? Left, how many? And then is it going to go up or down at all? Down 3? All right, we'll see. We'll see. So Robbie's saying translation, left 4, down 3. He is predicting it pretty good there, actually. I think it's going to be right. Okay. So A transforms to become what? What do we call it? A prime. B is transformed to B prime. C transforms to become C prime. All right. And then, so we're going to x coordinate 0. And what are we going to do to that x coordinate 0? Subtract 4. Subtract 4. And the y coordinate we're going to do. Subtract 3, right, is y minus 3. So we're going to take this y coordinate 4 and do 4 minus 3. So I'm going to write that in here. If you guys feel comfortable doing that, like mental math and just like doing it, that's fine. Or if you want to just use a calculator to do it, that's fine. I'm going to show the work for this one just so you can see it. You can get that part. B thing. B's x coordinate is going to be 3 minus 4. And then B's y coordinate, 0 minus 3. Okay. And again, that's C prime right there. It's going to be 0 minus 4 and 0 minus 3. Okay, and so I'm going to go ahead and just make sure we get those coordinates in there all right. So that means A prime is really negative 4, comma 1. B prime, when I do that math there, 3 minus 4 is negative 1. 0 minus 3 is negative 3. And C prime is negative 4, comma negative 3. Okay, so those are our points. All right. So now let's graph. So A prime has coordinates negative 4, 1. So negative 4, 1. There. I'm going to go ahead and label that A prime. All right. B prime has coordinates negative 1, negative 3. And then C prime has coordinates negative 4, negative 3. Okay, so there it is. If you guys would like, by the way, I have colored pencils. Would anyone like colored pencils for their notes to like draw the different color? You guys are okay? You want some? You want to use a different color for the image, like me. Like I'm doing different colors there. Anyone else want colored pencils? If you decide you do want colored pencils, they're over here. We'll grab them. And by the way, this is the typical kind of thing you'll see. Normally, the pre-image is like blue or something like that, and then the image will be like red. That's typically what you'll see too. So that's why I'm doing it that way. Anywho, okay. So, what kind of transformation was this? It is a translation. You got it. Okay, it was a translation. And let's see if Robbie was right here about the direction. He said left 4, down 3. So let's see here. So let's take point A, go left, 1, 2, 3, 4, and down, 1, 2, 3, and there's A prime. Take B, left, 1, 2, 3, 4, and down, 1, 2, 3, there's B prime. And take C, left, 1, 2, 3, 4, and down, 1, 2, 3, and there's C prime. So Robbie is exactly right here. Okay? So Robbie didn't even have to do this little work right here. He was able to read the transformation, and he could perform that transformation on those points without having to do this work, and that's fine if you want to do that. Okay, that's fine. Think about it this way. If you guys remember, back when you first learned how to graph lines, probably the first way you did it was using a table, right? You would pick some x coordinates and write those down, and then you plug those x coordinates into your line and get the matching y coordinates, and then plot those points, and then you draw the line, right? That's this. That's what we just did right here. We have these kind of original points, we plug them into the transformation, we got our calculations here, and we got our image points now, okay, the images of those points. However, eventually you guys were able to learn that, well, wait a minute though, I see some patterns here, right? For example, in slope-intercept form, you know that you can just graph the y-intercept and then use the slope to get more points, okay? Well, that's kind of like what Robbie was doing. He was able to see, oh, this just means it's going to be a translation, left 4 and down 3. And so, skipping this, he could have just gone left 4, down 3 for A prime, left 4, down 3 for C prime, left 4, down 3 for B prime. And that's fine for you to do that. You don't have to do these. However, if you see a transformation you're unfamiliar with, then you should do the table, right? That's what you can fall back on. All right, let's try another one here. So that was, in fact, a translation. All right, so let's look at another one. All right, we'll do the same kind of graph, so from -5 to 5. Okay. Oh, and you don't have to number them. In fact, I'm not going to number them. I'll just number my x-coordinate there, my x-axis, and a couple points on my y-axis. All right, so I'm going to limit. I'm not going to label everything there. It's faster that way, too. I will call this the y-axis now. Okay. All right, so let's see here. Let's graph R, S, and T. Let's say R is coordinates -4, 3. S is coordinate -1, 3. And then T is coordinates -4, 1. Okay, so there's the triangle RST. Okay, we're going to perform a transformation here. So now the transformation is going to be this. We'll take the coordinates x, y, and we'll make those become -x, comma, y. Okay. So notice, do the y coordinates of our points change? No, so they're going to be the same height off the axis, right? So S is not going to go up or down because its y coordinate's not changing. But what is changing? The x coordinates, right? We're going from positive x to a negative x. So again, let's write these out. So R, we said, had coordinates -4, 3. S has coordinates -1, 3. And then T has coordinates -4, 1. Okay. Alright, so Mitchell, what will R prime's coordinates be? If R was coordinates -4, 3, what are R prime's coordinates going to be? Under my transformation here. Yeah, +4, 3, exactly right. The -4x coordinate it'll be a -4, which just means it becomes positive. Oops, I should put R prime there. So R prime becomes +4, 3. All right, Mitchell, what about S? What will S prime be?
1, 3.
+1, 3. That's right. And go ahead and just give me what's T prime going to be? 4, 1. That's right. Okay. So the negatives kind of cancel out there. The y coordinates stay the same. So let's plot these points and see what happens. So 4, 3. So R prime 1, 3. S prime. And then T prime is 4, 1. Okay. So someone will raise their hand and tell me what kind of transformation is this? Blake. It's a reflection. Okay, can you be more specific? When you reflect, you normally reflect over something, right? So Blake, the y-axis, exactly right. It's a reflection over the y-axis, okay? Or you could say it's the line x = 0, okay? So you could say it's a reflection over, bless you, the y-axis, okay, or over x = 0. That line x = 0. X = 0 is the y-axis. X = 0 is the y-axis. Because all along the y-axis, x coordinates are 0. So x = 0 is that. Okay. So yeah. Very good. Questions on any of that? All right, let's flip it over. Let's do some more here. Flippy, flippy. Okay. Ooh, all right. I guess I'll do that. All right, so let's see here. let's, again, another graph, same size as before. We won't deviate from that. Okay, so 5, 4, 3, 2, 1, 0, 1, 2, 3, 4, 5. Okay, so, and then, okay, X, Y. Okay, so same size there, 5 by 5, or -5 to 5, -5 to 5. And plot the points here. Let's say J will be at 1, 1. J will have coordinates 1, 1. K will have coordinates 2, -1. And then L will have coordinates -2, -2. Okay? And then connect the dots there will create that little triangle. Ugh, I didn't do a very good job there. Okay. There it is. JKL. Now let me give you guys the transformation. So here we're going to do x comma y is going to transform to 2x comma 2y. Alright, x comma y is going to transform to be 2x, 2y. So we'll put I'll list out our original points here. So J is coordinates 1, 1. K is coordinates 2, -1. And L is coordinates -2, -2. Alright? So why don't you guys go ahead and do that transformation. Okay, go ahead and do it. Okay, go ahead and do it. Get those new coordinates. And tell me what's going to happen. Some of you guys might be able to look at it and tell me already what's going to happen. Look at it already. Transform those points. Get J prime, get K prime, get L prime. And then plot them. Exactly, yeah. The 2 next to the X really just means 2 times the X coordinate. Same thing with the Y, too. Yep. Good question. Yep. Oh, I see. You added 2 to them. Does it say 2 plus X? What does it mean when the 2's next to the X like that? Multiply. Yeah, that's what it should be. That's what it should be. Multiply. Doing okay, Tristan? So multiply. Yeah. Usually, yep. Plot the points and see what it looks like. Okay. So once you get those points and you feel confident in your answer, once you feel with those points, you feel confident in your answer. Plot them. See what happens. See if you describe what happens. This is that's K prime. I believe that's K prime. So that's what is it? Yeah, it does look right? Oh, I think. Okay, careful. What's L's coordinates? Yeah, so that's why. So you did it correctly, but with the wrong point. That's all. Good. Good. Let's go there, right? We gonna try it? Give it a shot. I don't know. Corey, what's the matter, bud? You did? Okay, good. You got it already. Yes. Okay, so, okay, -2, -2. 2 times -2 gives you -2. 2 times -2 gives you -4. So you fix that, and then I think it'll be okay.
So confused when I get the new line.
How you can do points? Take your coordinate right here, 1, 1. Okay, that's your original, see? And you're supposed to then take the x coordinate and multiply it by 2. So 1 times 2 is what? 2. So put a 2 there. Okay, and then 2 times y, well the y coordinate's 1, so what's 2 times 1? Does that make sense now? Do the same thing for this point now. 2 times 2, and then 2 times -1. Okay? We're ready to coordinate. You okay, Courtney? So the coordinates for J, I mean, you just have them right there listed, so you can then write those coordinates down and then do the multiplication. Question?
Yeah, that's good.
You do 2 times the x coordinates, so 2 times 1, 2 times the y. So each x coordinate is multiplied by 2. You see that? Okay. Yes. -4, -4, so that should be, because it's -2, -2, yeah. Okay. So you all had some chances to look at it here. So J prime. All right, J prime, let's go to Alex. What'd you get for the coordinates for J prime there, Alex?
I got
2, 2 is right. Okay. Let's see here. Oh, he's not here. All right. Let me call some other people here. Colin S. What'd you get for K prime, Colin S?
4.
Good. Exactly right. Good job. Excellent. And let's go to Gabe. L prime, Gabe. What'd you get? -4, -4. Exactly right. Okay, we're multiplying all those coordinates by 2 here. Do these two numbers have to be the same? No. I could just as easily say 2x and 3y there if I wanted to. In this case, they're both the same number. Okay, let's see what happens when we're multiplying both coordinates by the same number, 2. All right, so J prime has coordinates 2, 2. Like a ballerina. 1, 2, 3, 4, down to K prime, and then -4, -4, so -4, -4, L prime. Okay, so draw those together there. All right, so what has happened to our shape, Antoinette? Dilation. Can we describe it even more? So, can we describe it any more than just dilation? It got bigger. Any idea by how much did it get bigger by? 2 times bigger. What kind of gave it away, Antoinette? Yeah, we multiplied by 2, right? Which here's the thing, though, right? So, for example, if I were to measure JK, like using a ruler or using a distance formula or something like that, if I found the distance from J to K, what could I do to that distance to get the distance from J prime to K prime?
Double it.
Yeah, double it, times 2, okay? This distance is doubled to get this distance. This distance right here is doubled to get this distance, and this distance right here is doubled to get that distance. Okay? So yes, it does work like that, okay? Dilation, and so we call that a scale factor 2. So dilation, okay, scale factor of 2. Okay, now, one thing I want to point out here, and we'll get more into that when we do more dilation stuff. A dilation requires that you multiply by the same number for both of these. So both the x and the y have to be multiplied by the same number in mathematics. Okay, in geometry. You know, yes, multiplying by different numbers will still result in a bigger or smaller picture, but it won't be a dilation. Okay, it won't be a dilation. It'll just be a transformation. We don't have a name for it. Okay, so now that we've kind of gone into that here, okay, maybe you guys thought we were going to do a reflection next, right? Hopefully. Maybe you're thinking that. Anyway, so I want to talk about 2 things here. How do these two transformations differ from this transformation? Debbie? They're not changing size, and they're not changing what else? What else doesn't change? Well, the location does change. Size doesn't change. Does the shape change? Like, do we still have triangles here? Yeah. Here the shape does change. Or sorry, here the shape doesn't change either. I guess it's still a triangle. So maybe I shouldn't have said it that way. But anyway, you're right though, Debbie. That's the key thing here, is that the size is changing here. The size is not changing here. Okay? And so we group together. That's why we kind of treat these things together. Translation, reflection, rotation as one. We kind of group those together, and dilation we kind of keep off to the side, because dilation is a little bit unique in that case. Since translations, rotations, and reflections all keep the same size and the same shape and all that stuff, we call that a rigid motion. Okay, transformation. We used to call it an isometry, I-S-O-M-E-T-R-Y, isometry. Okay, that's what we call those kind of transformations. All right, the sides, angles, and shape stay the same. Okay, and the examples that we have of that, the examples of the transformations we have of that, those are the reflection, the rotation, and the translation. We haven't done a rotation, that's right. Okay, we're going to look at one here, hopefully, in a second. Okay. Ooh, actually. Oh, I do. Okay, I do have one here. Okay, cool. All right. So those are the ideas. Those are called rigid motion. Rigid, right, means to not move. You hold steady, right? If you hold your body rigid, that's like it doesn't move or anything like that. Okay, rigid, unmoving. Okay, it doesn't change size or shape. And so then the other ones we call non-rigid motion. Okay, so just put the word non in front, non-rigid motion. And that means the sides, angles, or shape do not stay the same. Okay, it's kind of like, well, duh. If it's not rigid, that means it doesn't stay the same shape. And of course, that's the key one we have is the dilation, but there are others too. But we don't have names for those, really. Okay, dilation and others, we'll say. All right, we'll do two more here, and then we'll be done. But I would only suggest you guys write down this next one, and then the very last one you don't really need to write down. I'm just going to kind of show it to you. Okay, so this next one, let's do that, and then we'll I'll do one more for you just so you can see it. All right, so let's take let's start with and I'm going to do it a little bit differently here. I'm going to start with the transformation. Okay, and I'm going to give us points. So we're going to do this without a graph. Start out, and then we'll graph it so you can see what it looks like. So here we're kind of just doing a blind transformation, no graph, but there's the information we're getting. We're going to have A with coordinates 1, 2, B with coordinates 4, 2, and C with coordinates 3, negative 2. And then we're going to do something kind of weird here. Okay. Yeah, our x-coordinate, the x number, in the x-coordinate position, the x-coordinate switches to what over here? It's a y-coordinate now. And then the y-coordinate switches to the x-coordinate, and we make it the opposite, too. Crazy. Yes, so the x and y swap places, and you make the opposite, you make the y-coordinate opposite. So let's just see an example here so you can kind of see it happen. All right, so 1, 2. 1, 2, for example. 2 is the y-coordinate here for A. Where is that 2 going to go over here? It becomes negative 2 for the x-coordinate. Comma, and then what's going to go here? The 1, right? The 1 switches places to the y-coordinate position, like that. And you might be wondering to yourself, what the heck kind of transformation is this going to be? Okay? So for 2, all right, now we got to see what that's going to switch to. Again, the y-coordinate there is 2, and that becomes negative y for the x-coordinate. So it's negative 2 for the y, for the x-coordinate there. And then 4 x-coordinate becomes the new y-coordinate. Okay, so they swap again. And lastly here, 3, negative 2. Someone want to do this one for us? So Kwanya, you go for it. 2, 3. Yep, that's right. 2, 3. Okay, 2, 3. It's 2, 3. All right. So you're like, what the heck could this possibly be? Right? What could this possibly be? So let's see here. Could be. Could change the shape. Right. Maybe it could change the shape because we really messed around with the coordinates, didn't we? So I'll graph a little coordinates there. I'm going to graph my original just so we can have something to refer to. So A has coordinates 1, 2. B has coordinates 1, 2, 3, 4, 1, 2. And C has coordinates 3, negative 2. Okay, so there's ABC. That's our original triangle. I know Ms. Woodmire's not very creative with his shapes, but I like triangles because they're like the smallest number of, like the least work you have to do to make the shape because it's only 3 points, you know. If we start making other shapes, it's a lot more points to transform, and then it's a lot more work for you guys, and I'm just trying to save you guys the time. All right, now let's graph these other points. A prime, negative 2, 1. All right, there's A prime. B prime, negative 2, 4. And C prime 2, 3. Now you should connect the sides in the same way, right? So A prime connects to B prime, B prime connects to C prime, A prime connects to C prime, like that. No. Why no? What is it? It's a rotation. Can anyone say what angle? What degree? What number of degrees do we rotate? Yeah, 90 degrees, or a right angle rotation. Which direction did we rotate?
Left.
Yeah, it's kind of hard to describe, right? Because, for example, we got to be careful here, because I rotate, you know, if I say this, it's like I'm rotating, yeah, I'm kind of rotating to the left there. Okay? Yeah, we want to use the clock directions here for this. We want to use clock directions. So, and this is specifically which direction? Clockwise or counterclockwise? Counterclockwise. Yeah. So, right. No, actually, it did not translate. It does not translate. What's the center of rotation? So what am I rotating around? What point am I rotating around here? Eric? The origin, exactly right. And we're going to be mostly focusing on rotating around the origin, especially when it comes to like coordinates notation like this. We won't be doing very much rotating about other points, okay, besides the origin. So if you want to kind of see that 90-degree angle, let me show you how you can see that 90-degree angle a little bit easier. Because some of you guys might look at this and say, I'm not really sure I see the 90 degrees. Let me show you. If you draw a line from A, I'm going to draw a little dotted line here, from A down to the origin, because Eric said that's our point of rotation there, and you draw another dotted line from A prime to the origin, its image, okay? So you draw a line from A to the point of rotation and to A prime then as well. What angle do you see between those two lines? The L is there, right? If I take a corner of my paper, okay, there it is, right angle, okay? So that's 90-degree angle. 90-degree angle, 90 degrees counterclockwise. I want to put CCW. Now, okay, I'm going to give you one more question here, and I'll have you guys get started. We'll just get started on the assignment. I think I won't have you do the next one. Okay. I have one more question though. There's actually a way to rotate this in the clockwise direction. If we go 90 degrees in the counterclockwise direction, how many degrees is it in the clockwise direction then? So, for example, to get from here to here, I have to go 90 degrees. How many degrees would I have to go if I rotated this direction? 270, exactly right. 200, it's not a random number. Eric? Yes. This, you could also say, is a 270-degree clockwise rotation, too. Because, right, we know a full circle is 360 degrees. 90 degrees this way. I'll tell you in a second here. Shh, listen up. Okay, listen up. I'll show you here. Okay, 90 degrees this way, okay, means that if I go 270 degrees, which is 360, okay, minus 90. 360 minus 90 gives you 270 degrees the other direction. So, yep, 270 degrees clockwise. Okay. Now, so there you go. You could describe it two different ways there for that rotation. 90 degrees clockwise, or the other direction, 270 degrees counterclockwise. If I wanted to rotate 180 degrees counterclockwise, this might be too much to imagine here. If I wanted to rotate 180 degrees counterclockwise, what would that direction be in clockwise? Yeah. So if I want 180 counterclockwise, what would that be clockwise? 180 again, 180 again. Because 180 from one direction is 180 the other direction, because, yeah. We'll look more at that, so don't worry too much about that if you don't get that. We'll look more at that when we look specifically at rotations, okay? If you're able to get that this is 90 degrees, that's great. If you can get 270 degrees there, that's really great, but that's not as important right now. I'll make sure you get that 90-degree rotation.
So for clockwise, what's the 360 minus whatever?
Yeah, for the other direction, you just do not 360 minus whatever that measure is, exactly right. So 90-degree counterclockwise, I'm going to abbreviate that CCW rotation. Okay? Or if you're like in England and stuff like that, they don't say counterclockwise, they say anti-clockwise. So anyway, 90-degree counterclockwise rotation. Yeah, they don't say counterclockwise, they say anti-clockwise. Alright, anyway, there you go.